A contingency table is a table that summarizes all possible combinations of two categorical variables. When we talk about categorical variables, we mean variables that represent things that are qualities. Now, we've used Venn diagrams in the past to organize similar types of data. Here's an example we did back in Chapter 1. A survey was conducted asking people if they have cats and/or dogs. This Venn diagram takes that data and displays it with circles representing sets. So you have a set of people or a circle that represents people who have cats, a circle or a set that represents people who have dogs. Where you have overlap would be people who have both a cat and a dog. Where you have a number outside of the two sets, you have people that are neither owning a dog nor owning a cat. So these 13 people would not be in either of the two sets and therefore don't have a cat or a dog. Now we can take that same information, which are information about two categorical variables, one for whether you have a cat, one for whether you have a dog, and put that in table format. This table will be called a contingency table. We take one of the two variables, in this case have a dog, and we put it into in this case, columns. So you either have a dog or you would have people who don't have a dog in a second column labeled no dog. We put the information about cats into rows. So we have people who have cats in one row and people who don't have cats in the other row. And where rows and columns cross, for instance, in this first region in the table, this would be where you have someone has a dog and has a cat. Whereas if we look at this region, you would have someone who doesn't have a dog and doesn't have a cat. So you use these cross regions to put in the appropriate number for whether people have a cat, a dog, or one of each. So let me erase those marks and let's go ahead and fill in this information for this particular situation. So first off, let's look at having a dog and having a cat. That would be the location for both in our diagram, and that would be 8 people, the overlap. 8 people have both a cat and a dog. If we continue to the right, we would be looking at having no dog and having a cat. So this would be where having a cat and no dog overlaps. So that would be just the cat people that don't have the overlap with the dog people. So that would be 15 people. Let's move on to the next row down. The next row down represents no cats, but the first entry in the that row would be having a dog. So if we want to have a dog but no cat, that would be the 12 people who are in the dog circle but not in the cat circle. So that would be 12 people. And then if we continue over to no cat and no dog, that would be the people who are outside of both sets, which would be 13. So we basically just look at the information just slightly differently, but it is still the same 4 numbers. One advantage, though, of a table is we can expand that table to include some very useful information, and that is totals. So usually contingency tables will have totals, or if they aren't given with totals, I recommend that you create them because those totals can be helpful in answering questions about the situation. So you can total up how many people have cats. 8 and 15 would be 23. Now how that relates to our Venn diagram would be adding up the entire cat circle. 15 and 8, there are 23 people who have cats. Then we could total up the no cat row, and that would be 12 and 13, which would be 25 people, and that would represent those people who are outside of the cat circle, 12 and 13. So we have those values as well. We could continue and total up the column with dogs. That would be 20 people who have dogs, and then the people who don't have a dog, 28 people. And you could look at similar things over in the Venn diagram related to that as well. Now the totals of the two columns should add up to the total people that are in the survey. And the totals of the two rows should also add up to that total. So this is another good check to make sure you have everybody, is that your totals for the rows and the columns should add up to the total number of people in the scenario or who we surveyed. So 48 people in the survey altogether. So here's an example of a contingency table. Let's use this contingency table we just put together to answer some questions about this scenario. First, how many people in the survey did not have a dog? All right, so we want to know who didn't have a dog. The no dog part of the table would be in this second column of numbers. We have 15, 13, and 28. Remember, the total is 28, and that's what it's saying. It doesn't say, it doesn't have a specify between having a cat or not, so we'd want the total number of people with no dog. So that would be 28 people. So here those subtotals come in handy. The next question is, what fraction of people surveyed had both a cat and a dog? A couple of things to point out here. We have an and, so we want somebody who has both a cat and a dog, overlap between those two. The second thing I want to point out is that this is talking about the people surveyed as a fraction. All right, so if we are working on a fraction, we've got a fraction bar, and it's the fraction of people surveyed, so that would be the denominator. The total number of people surveyed would be 48, and that would be our denominator of our fraction. Now our numerator is going to be related to who had both a cat and a dog. If we go up to our table, we would look at where we have the dog column overlapping with the cat row. So that would be 8 people. So we have 8 people out of 48. That's the fraction of people who had in the numerator a cat and a dog, and in the denominator out of the total. Now, when we get a fraction, we'll often want to simplify it, especially you'll notice this in a lot of our homework, online homework questions in My Open Math. They'll ask you to have a simplified fraction as an answer. To do that, if you need a little reminder of simplifying fractions, we would simplify by taking out something as common to both the numerator and denominator. And when I say take it out, divide it out. So we want to look at what would be common. Now there is a 2 common between 8 and 48, but there's also a 4, and if you look closely, an 8 will go in evenly into both these numbers. So I'm going to take an 8 in. It's always better to take the most out you can. 8 divided by 8 is 1. 8 divided into 48 is 6, so I'm going to get left with a simplified fraction of 1 over 6. Now that would be our fraction answer for this question. But if I wanted a percent instead, because what we'll learn is that probabilities can be expressed as fractions or percents, to calculate that percent, we would take the fraction and we would divide. 1 divided by 6. And the way to remember this is we say 1 over 6, divide the same way, 1 divided by 6. When we do that, we'll get a decimal that goes across your calculator forever, 0.1666666, etc. To make that into a percent, though, this is the decimal. We would multiply by 100, or we would move the decimal point. You can do either one, either move the decimal point or multiply by 100. When I do that, I'm going to get 16.66666, but typically we round percents to the first decimal point. At least that's what I'm going to request in all worksheets, 16.7%. So we've got the fraction of 1/6 and then the percent of 16.7%. That would relate to who in the survey has both a cat and a dog. Part C, what fraction of people surveyed had a cat or a dog? So this is a little bit different than our last question because it says or. And I want to remind you that or in mathematics is inclusive. What that means is that we're looking at all people who have a cat and all people who have a dog. Let me circle some of that in the table. If I want to look at all people who have a cat, that would be this row. If I want to look at all people who have a dog, that would be this column. Okay, and notice I'm not circling the subtotals because you have to be careful when you want to combine in a contingency table values that are in both a column and a row. And the reason for that, if you look really closely here, and I'm going to highlight, when we look at the cat values, that's 8 and 15. If I highlight the dog values, that's 8 and 12 here. Notice the 8 comes up twice. Because the 8 comes up twice, if you use the subtotals 20 and 23, you will not have the correct value of people who have a cat or a dog, because you will have those 8 people counted twice. So it's very important that you only count these people once, that you count the 8, the 12, and the 15 exactly once. So that would be these people who have a cat and a dog, 8 plus 12 plus 15, that would be 35. Now if I want the percent, the way I get a percent is to first make the fraction. So that would be 35 out of the total number of people surveyed, which is 48, and then divide. 35 divided by 48 would give you 0.729, I'm rounding there, or moving the decimal point, 72.9%. Again, you would divide the numerator and denominator. So the way we say it, 35 over 48 means 35 divided by 48, and then move the decimal point 2 places, or if you prefer, multiply by 100 and round, 72.9%. Of the people who were surveyed had either a cat or a dog. All right, let's move on. Part D, what percentage of the people who had a cat also had a dog? Now this may seem like it's the same question in terms of saying and, but it's not. If we look at the way this is phrased, this is saying what percentage of people who had a cat. What this means is we're only looking at the people who had a cat, and we want to answer a question about how many people also had a dog. So we are only looking at the people who have cats. So I'm going to highlight that up in my table, only the people who have cats. So that's 23 people that we're looking at. And then we want to know how many of those people had a dog. If we only look at the people who had a cat, 8 of them had a dog. So that would be a fraction of 8 over 23. And to make that into a percent, we divide. 8 divided by 23 and then multiply by 100% gives us 34.8% when you round. So Part D is about people who have both a cat and a dog, but it's based in the perspective of studying just the people who have a cat. You're only looking at the cat people. And the wording is kind of telling you that. So you have to look closely at the wording. Part E looks at this from a different standpoint. This time it says what percentage of the people who had a dog also had a cat. So here we're looking at the people who have a dog. So if I go back up to the table, now I'm looking at only the people who have dogs. So I'm only looking at these 8, 12, and total of 20 people. So I'm looking at 20 people altogether, and 8 of them had a cat. So that would be 8 over 20, converted into a percent by dividing and then multiplying by 100, that would be 40%. So the percentage of people who had a dog who also had a cat is 40%. So we're only looking at the dog people. So these last two, it's a matter of perspective. And you want to look closely at the wording to know how you want to consider that.